So in this question here, A and B are not independent events. And what we're given is to work on is the probability of A given B has already happened is 0.4. And the reverse of that, the probability of B given A has already happened is 0.25. What we're asked is, what's the ratio between the probability of A and the probability of B? So what's that? So how are we going to go about that? So they're not independent events, and we've got conditional probabilities. So what we can use here, we could use Bayes Theorem. So Bayes Theorem. So what that consists of is a formula for us to use given these two bits of information. So if I write these two out separately, so I have the probability of A given B has already happened, and the probability of B given A has already happened. I can write this out by using Bayes' theorem. So that's the probability of A intersection B over the probability of B. And then this one, probability of B given A, that's the probability of B intersection A over the probability of A. So that's what we can work on. And we know that these two are given in the question. So the first one is 0.4. So I'll write that as 2/5. And the second one is 0.25. I'll write that as a quarter. Okay, now what can I do next? I've got my probability of A and probability of B, which is what I want. They're in my denominators. Then I've got this intersection in my probability in the numerators. A intersection B and B intersection A. So if I just draw a quick Venn diagram like this, if I've got A and B here, this centrepiece, that there is the probability of A intersection B, but it could also be read as B intersection A. So they are the same actual calculation and same value. So these two are equal. So what I'm going to do now, I'm going to write these two out and set them equal to probability of A intersection B, and the same for this one with these two equations. So if I do that, probability of A intersection B, that would equal 2/5 times the probability of B. So that's equation one. Second equation, get this one on its own. Now I can write that as the same, as they are the same thing. So then I've got probability of A intersection B, that equals 1/4 times the probability of A. Now as these two are the same and the same value, then that means that these two here must also be the same value. So I can now write these and set them equal to each other, and let's see if we can get our ratio that's required. So now I've got 2 probability of B over 5, so that will work for that, and set it equal to this one, which equals probability of A, obviously multiplied by 1, it doesn't change, and then divide by 4. Okay, so now for a ratio between probability of A and probability of B, what I ideally want is a probability of B on this side and then some sort of fraction on this side, because a fraction is basically a ratio but written in a different way. So if I bring the probability of B on this side, I will then have 2/5 equals probability of A over 4 times the probability of B. So basically just divide both sides by the probability of B. That's what I would get there. Then I've got my ratio set out as a fraction. All I need to do now is multiply both sides by 4. So if I do that, I'll have 8/5 equals the probability of A over the probability of B. And now I've got my ratio set up. So if I write this, instead of like this, I wrote it as a ratio. I could then write that in terms of this ratio here as 8/5 corresponding to numerator and denominator. So then that would give me 8/5. And that would get me to the answer of the question, what's the ratio between probability of A and probability of B? They're in the ratio of 8 to 5. Okay.